guys, and welcome back to our channel. So in this video I'm going to walk through and give you some tips and tricks on how to ace your physics IA. So I did physics at SL level, and the topic I will be covering in terms of my IA, which was on large angle pendulums, would be a lot simpler compared to a topic you would typically cover at like HL level. So if you are doing HL level physics, I would definitely recommend scoring for a topic that fits into the HL syllabus. So yeah, without further ado, let's get to it. So hi guys, I'm back. So today we'll be walking through my SL Physics IA. So just for some background, I did my IA on the motion of releasing a pendulum at angles greater than 15 degrees. So basically when we release a pendulum at a displacement of 15 degrees or less, the pendulum is said to undergo something called simple harmonic motion, which is where the restoring force is directly proportional to the negative of the displacement. However, when the angle of displacement is greater than 15 degrees, the pendulum's motion does not satisfy this, as the angular acceleration of the pendulum starts to have an effect. So my IA was about what actually happens to a pendulum's period when you release it at large angles. And as a result, my research question was this. So why does a pendulum not undergo simple harmonic motion when its angular amplitude exceeds 15 degrees? And how does the period vary according to the angle as a result? So yeah, you definitely want to have your research question stated as explicitly as possible. You could also have this as an aim. I've seen some IAs that do this, and it actually doesn't matter what you do, but you need to have either, because essentially this is what lets the examiners or whoever is marking your IA to identify what's going on or what your IA is going to be about. You don't want them to be searching for it or even like confused to what you're writing about in the first place. And putting it at the very beginning helps them to identify it right away. So what do you write in your research question? So it needs to be the research question or the question that you're answering. So in my case, it's what happens when you release a pendulum above 15 degrees? And why does this happen? So if your research question is straightforward and if your topic isn't too complicated, it's okay for your research question to sound kind of like simple and not be that long. At the end of the day, you need to communicate your idea effectively with your mocker. Now, moving on to the next section of my IA, or your IA in general, and this is your introduction. Your introduction is your time to lay down all the theory associated with the topic. And this is really important because your introduction is kind of setting the scene for your marker for what is about to come. This is where you talk about what the topic is, the underlying physics associated with it. And I definitely recommend starting off with what the underlying physics is, talking about the formulas and the theories needed, and then talk about how this links to the topic you're investigating. If your topic isn't something that is readily found in the syllabus, for example, my topic was on large angle pendulums, and while we did cover pendulums at SL, large angle pendulums does require a bit of external research in terms of what approximations you're going to use, what's the formulas. So I recommend doing some research on the topic and then using those equations and formulas and theory that you found, explain them, and talk about how it's used and why it's important. You kind of want your introduction to have some sort of flow to it, which is kind of representative of your progression into refining and developing this topic you chose and making it your own. You definitely don't want any like grammatical errors or missing words, because this is kind of the section that generally leaves a good first impression to the marker, and good first impressions are really, really important in your IA. So in my IA, I started off with my personal engagement section, and for me, it was like, why did I want something to do? Why did I want to do my IA on pendulums? And I think this is really nice because it starts off with something that was kind of like a perfect segue into developing my topic even further. You get personal engagement marks throughout your IA, but because you kind of need to like show that you're interested and you've kind of changed the research and you've kind of made it your own. But by putting it at the beginning, it kind of checks off one thing off the list. And it doesn't have to be anything revolutionary as well. You could be, or I recommend you be, as honest or as honestly sounding as possible. You could take one experience from your life and then extrapolate it a bit to like fit your needs. But yeah, so after that, I talked about the underlying physics of my IA, in which it was what simple harmonic motion is. And this was really because it was the basis for the rest of my calculation. So I included a little diagram here and the formulas that are associated with simple harmonic motion. I then moved on to talk about what happens to a pendulum when it's let go from large angles, which is my IA essentially, and the resulting formulas that are associated with it. In my IA, I decided to use an approximation to calculate the period of oscillations because, as you can see in my introduction, actually to calculate the period is an elliptical integral or a series, and I hadn't actually learned how to solve these during my time in the IB. So it would be really weird for me to like go out of my way and try to learn how to solve elliptical integrals. So I use an approximation to calculate this period of oscillations, and then I would compare it to my experimental values and see what the difference is. Another tip I would definitely say is to make sure you justify why you did what you did where needed. For example, I could not just say I was using an approximation and then left it there without justifying to my marker why. Because in my case, I could have chosen any approximation, and definitely using the exact series would be more accurate, and you'd want to find the most accurate solution anyway. But for me, I didn't know how to solve elliptical integrals, and it would actually be a really long process if I did. And I could use an approximation and make a linear graph, and that would also make it easier to see the relationship between my amplitude and my period. And then I talked about how I did some research and I chose the best approximation and that was by finding the errors. So yeah, that was kind of the end of my introduction. And the next part of your IA is your investigation. So after your introduction, we move on to the main body of your IA, which is the investigation that you're conducting. So you firstly start off with your hypothesis, which is essentially what you think is going to happen, what you think your results are going to be, and this is what you accept or reject in your conclusion. So the basic structure for your hypothesis is you first and foremost state what you think is going to happen. Usually this is only like one sentence long. After that, you then need to explain why you think this is going to happen. And you use the underlying theory or the underlying physics you talked about in your introduction to justify this, and you include this in your hypothesis. So in my hypothesis, my one line prediction was that my pendulum would not undergo simple harmonic motion at large angles, and the period will not be constant. So I said as the displacement increases, the period of oscillation will increase, and this was my justification. I used the elliptical integral since it was the accurate representation of the period that I talked about in my introduction, and I said that I was going to use the Lima-Aroon approximation. The thing I included in my IA was a section on preliminary testing. Um, I've seen a lot of IAs doing this, and I actually really like this because it kind of adds on to showing the markers your thought process and how you made this experiment or this investigation your own. So I did this before my main investigation, and it shows my thought process, and I guess the steps took, I took at least to finalize the design of my investigation. And this shows to the markers that you haven't like copied and pasted someone else's method and did your investigation according to that. It also helps you justify your methodology in terms of like the materials you use and how much you use of it. That was kind of the basis of my preliminary testing actually, because I needed to suspend my pendulum from um a point and I could have used a string, but because I was using large angle pendulums, the string would not be able to generate enough tension to be released at angles above 90 degrees and therefore would just like collapse onto itself. So from my preliminary test, I decided that, oh, I could use thick metal wire and that would maintain the tension of the pendulum better instead of like string. So I just used a hanger and I just opened it up for it to be a thick metal rod. So that's my preliminary testing. You could even do like a preliminary testing for just to see if your experiment works and then talk about it because preliminary testing is very important and it's also really important when you do a science EE because well it's more important in a science EE, but in your science IAs it's also I guess very recommended to actually have some sort of like before experiment before your main one. Yeah. So the next thing you need to include is your variables that you need to account for. So these are your independent, dependent, and controlled variables. So just a quick run through. Your independent variable is what you're changing intentionally to see an effect. And your dependent variable is the quantitative measure of the effect. So, for example, my independent variable in this investigation was the angles at which I would release the pendulum for, and I started from 40 to 120 in increments of 10 degrees. The dependent variable of my investigation was actually the period of my pendulum, and I used the way I measured this was by using Logger Pro. So I would take a video of my pendulum oscillating and then feed it into the software and then model the oscillations and then calculate the average time it takes for one complete oscillation. The next variable are your controlled variables. So these are the variables or the things you kept the same throughout your experiment. And if you did alter them, it would have had a significant impact on your findings. You could write about this in a paragraph, which is fine. I just did mine in a table as it's more clear and evident to the marker on what my variables were. I don't think it makes a difference as long as you're able to communicate effectively. And I told the way I structured my table was, and you, when you're writing in your paragraph, you definitely want to talk about it, but you want to talk about your control variable, how it would impact your investigation if it was changing, and what you did to reduce that impact. So, and once you talk about your control variables, it's a pretty nice segue to your methodology. So this was my methodology, and it doesn't actually need to be that long. You just really want to talk about how you conducted your experiment, the materials you used, how to set them up, kind of the usual things as you would write in a regular lab report. I would recommend to try include some nice diagrams here to show um, the layout of your experiment. So I used chemix.org, I think, to make my diagrams. So as you can see, got little like cute protractor there. But you could always use shapes on Word or even like just an image of your setup with arrows labeling each element. It doesn't really matter, but it's important that you kind of show some sort of diagram because well, it's a lot quicker essentially for your marker to see a diagram rather than them seeing like a whole page of how you set up the apparatus, even though you do want to include that as well. Um, on that note, it's also kind of important that you show that you haven't just used a method you found on the internet. It should seem like you've really thought about your experiment and you haven't just like copied and pasted someone else's method. Even like like definitely you want to be inspired by things off the internet. At the end of the day, an IA isn't like a novel experiment. You're definitely taking previous research and repeating that research. But yeah, somehow, I guess writing up your own method instead of copying and pasting it is definitely a good start. Another thing is that it should be really easy to understand. The marker who's reading it or anyone should be able to read these instructions and just do your experiment if they have the right resources. The next part of your IA is the results and processing section. So this includes your data collection, your graphs, and present your raw data. And this is really important because the way you process your raw data impacts what you write in your conclusion. So in your IA, the IB wants to see that you did your experiment, you've collected your data, and you've looked at your data and you've kind of modified it or used it in some formula, or you've presented it in a graph that shows that there's some sort of relationship between your independent and dependent variables. Graphs are really good in your IA as they can show a relationship really easily instead of talking about it with in 4 or 5 paragraphs. So for me, I had 2 graphs. So this was my first graph that was how my angular amplitude and my period varied for both the approximation and my experimental values. And this was my second graph, which was how I linearized my approximation. So you definitely want graphs in your physics IAs because you then want to explain their importance and how it's relevant to your research question in your conclusion. And it's also, it kind of shows that you've done some sort of like mathematical manipulation to your data. But I would also not recommend putting a graph that you can't tie to your research question, or putting in a graph because you need to put in a graph, because then it looks like you're brain dumping and then you don't know what you're really talking about. So alongside your graphs, you should have some sort of error calculations as well. And this goes for all science IAs, but all science IAs should have some sort of error calculation. In biology, you would have your like ANOVA or F-tests. In chemistry and physics, you might want to do standard deviation or even just like relative percentage error calculations and include those error bars in your graph to show that your results are statistically significant and as a result, they're reliable. So I had error bars in my first graph. As you can see, they're very tiny. So I'm just gonna scroll in. So you can't really see them, but essentially the whole idea is that you don't want these error bars to overlap, and if they do, it could mean that your results aren't statistically significant, and it could be a problem. You also want to justify these error bars. So for me, I definitely said, oh, there's a really high R squared value, and my error bars are very, very small. So there could be like a strong correlation between amplitude and period. And then I talked about what other errors could have impacted my investigation, such as systematic error, which would have caused it to shift from the origin, and parallax error of the position of the camera lens. And then I talked about the curve and my best fit line. Depending on what your IA is about, you're going to have different ways of collecting your data and processing it such that you can get the answers that you want. For me, it was mostly just getting my data, finding the relative percentage error, representing it in a graph, and then finding a relationship between my oscillation and my angular amplitude. So the final part of your IA is the conclusion and evaluation. And this is probably the most important part of your IA. So in this section, you're required to look back on your investigation, comment, explain your findings, and link it back to your hypothesis and ultimately your research question. And you also have to critique your methodology and your investigation as a whole. This is the part where the marker is kind of looking for your critical thinking skills, and they want you to recognize that at the end of the day, you're a high school student doing this experiment, and it's probably not going to be perfect. But for the IB, just recognizing and saying, oh, this investigation has its flaws is not enough. You also have to identify a possible solution for these problems. And this is what you talk about in your evaluation. So in your main evaluation, you want to talk about your strengths, your weaknesses, and the problems in your methodology that you can improve on. So in my IA, I divided my evaluation into 4 parts. So my first part was my conclusion. So in my conclusion, I accept or reject my hypothesis, and I talk about whether my results and my graphs support the hypothesis that I made at the beginning of my IA. And then I talk about, well, I give a little bit of a summary of the results. So this is where you don't want to brain dump every single point and every single results that you obtain, because that's not what the conclusion is for. The markers could always go back to your results and data processing section and look at your graphs and your raw data to see if there's a relationship. But you definitely do want to kind of summarize your results and talk about your results in terms of your investigation and your research question. So for me, I definitely talked about how the period of oscillation does not remain constant and therefore does not conform to simple harmonic motion, which was the first part of my research question. And then I talk about how my results do support my nonlinear proportionality and how it also satisfies the Lima-Aroon approximation. In my conclusion, I also talked about the errors, and you don't have to go into too much detail about it, but I would definitely recommend talking about like your regression values and my error bars, and talk about how why these errors and these small errors or big errors, why are they created? What does it mean for your results? So does this mean your results are really reliable? And why do you think these errors came to be? I mean, in every investigation, there's always going to be some sort of errors. So you need to identify them and talk about them a little bit. And I guess after that, I moved on to talk about my strengths. There wasn't a lot of it, but it's still important that you shouldn't be just identifying weaknesses in your investigation. Otherwise, it kind of makes it seem your investigation's a bit weak. You want to talk about your strengths as well. And then I moved on to my weaknesses. I definitely recommend having around 4 or 5 weaknesses for your investigation and dividing them into like paragraphs, and then talking about, and in each paragraph, you want to talk about what's the error, how it impacts it, and how can this be solved or how can this be rectified. And after I talked about my weaknesses, I went on and talked about extensions. So this is something that kind of shows to the market that you're kind of going beyond your investigation and you're thinking beyond your investigation and what this investigation can be used for in the future. So your investigation is a starting point. What could you do in the future using your results to discover next or to find out next? So that's something that I did talk about. And then, yeah, and then you move on to your bibliography and references. Keep in mind, you definitely want to be spending the most time on refining this section, as your evaluation is really important. And it's probably worth like 6 marks on the rubric, so it's pretty highly weighted. and it can make the difference between a 5 or a 6 or a 6 and a 7, especially if you're aiming for, I guess, the top marks. Yeah, so that is all. I hope you found this useful, and thank you for watching.